This lesson is talking about special parallelograms. And the first special parallelogram that we're going to focus on today is a rhombus. Now remember, all parallelograms have 5 characteristics. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. So no matter what parallelogram we have, they all have those 5 characteristics. Now with a rhombus, some other things start to happen. Okay? Remember, a rhombus is a parallelogram. So opposite sides are parallel. But with a rhombus, all 4 sides are the same length. That's what makes it a rhombus. So our first concept here, each diagonal of a rhombus bisects the 2 angles of the rhombus. So what happens is this diagonal will bisect the angles it goes from and to. Same thing with that diagonal. That diagonal will bisect that angle, the angles it goes to and from. Secondly, the diagonals of a rhombus are perpendicular. Remember, perpendicular means they intersect at a right angle, which is 90 degrees. Okay, so in this diagram here, we have a rhombus. These 2 diagonals, BD and AC, they are perpendicular. So in the middle, all of these angles are now right angles. All right, so our first example, we're going to find angle measures inside of a rhombus. Okay, these are all, both of these are both rhombuses. Okay, so we know that in a rhombus, all the sides are congruent. So we have to flash back and remember from the previous slide that angle 1 and angle 2 are now the same because that diagonal bisects this angle over here. And same thing over here. Okay? Now, a previous concept, opposite angles of every parallelogram are congruent. So if angle N is 120, I know this is also 120. Now, if I were to take out that triangle where you have 120 degrees, this is angle 1, this is angle 3. Both of these sides are congruent, which is marked. So this is an isosceles triangle. So, how do I find the measures of those 2 angles? Well, I know all triangles add up to 180. So first I'm going to subtract 120 from 180, which gives me 60. And then I'm going to divide that by 2, which gives me 30. So 30 degrees is both angle 1 and angle 3. Now we knew from the previous slide that the diagonals bisect the angles they go to and from. So I know angle 1 was 30, so was angle 3. And angle 2 and 4 are the exact same as well. Those are both 30 also. For this example, you're given a rhombus again, so I know all these sides are congruent. And it's a parallelogram. All right? And the diagonals are both drawn in here. Okay? So one of the previous concepts was the diagonals of a rhombus are perpendicular. So all of these angles inside of here are all of them are 90 degrees. Okay, so angle 1 is 90. Now, how do we get the rest of these angles? All right, remember, this diagonal cuts that angle in two. It bisects it, both sides. So if this angle over here is 50, so is this one. Same goes over here. These are both 50. Now that only happens in a rhombus. So I have angle 2 and angle 3 are both 50. Last, we have angle 4. How do you get angle 4? Well, pull out that triangle. You have a 90-degree angle. You have a 50-degree angle. And that's the angle in question. So add up 90 and 50. I know I'm going to take away from 180 because it's a triangle. So 90 plus 50 is 140. So I'm going to subtract 140 from 180, and that should give me angle 4, which is 40 degrees. Now we're going to talk about a rectangle. Okay? The diagonals of a rectangle are congruent. So in this diagram, FD, that's this diagonal, would be the exact same length as the other diagonal, GE. Okay? So we're going to use that concept to set up equations to solve and find lengths of diagonals of rectangles. So this example here says find the length of the diagonals of a rectangle GFED. So here's GFED. All right? I know FD and GE are the same length. So I'm going to take the expressions for those two diagonals and set them equal to each other. 2y plus 4 equals 6y minus 5. Now I'm going to solve this for y. First, we're going to bring the y's together, so I'm going to move the smaller y. So that gives me 4 equals 6y minus 2y is 4y minus 5. Next, I'm going to add 5 to both sides. So we get 4y equals 4 plus 5 is 9. Last, we will divide by 4. 4's cancel. So the y equals 9 divided by 4. Now 9 divided by 4, if you do that on your calculator, is 2.25. Okay? Now, again, we need to find the length of the diagonals. So I'm going to plug this in. I'm going to plug it in for either one of these y's. It doesn't matter which one we plug it in for because we know they're going to be the same length. So I'm going to take this one. 2 times, now y is 2.25, and then plus 4. I'm going to do that math right there. 2 times 2.25 is 4.5. And then I'm going to add 4 to that, which gives me 8.5 for the lengths. So both diagonals are 8.5 because they're both congruent. Next thing we're going to talk about is whether or not the parallelogram is a rhombus or a rectangle. Okay, so there are basically 3 ways to determine that. 3 ways to determine this. Okay? If one diagonal of a parallelogram bisects the 2 angles of a parallelogram, then it's a rhombus, which is what we talked about earlier. So if you have a parallelogram and the diagonal bisects the angles it comes to and from, then it's a rhombus. Okay? And all you need is one diagonal for that to happen. All right, the next concept, if the diagonals of a parallelogram are perpendicular, then it's a rhombus, which is what we talked about earlier as well. So if those 2 diagonals intersect at 90 degrees, then it's a rhombus. And then last, if the diagonals of the parallelogram are congruent, then it's a rectangle. Okay? Which is exactly what we talked about right here. Okay? All right, so here's a couple of examples. We're going to determine, is this a rectangle or rhombus? That's our question. So here we have example A. It says the quadrilateral. So let me draw a quadrilateral. I don't know if it's a rectangle. I'm just drawing a basic four-sided shape. It says has congruent diagonals. So I know, let's label this A, B, C, D. So I know from A to C is congruent to D to B. So DB. So that diagonal, this diagonal here, is congruent to that diagonal there. Now it also says this quadrilateral has one angle of 60 degrees. So I'm just going to put that right here. Okay? Now according to the diagonals being congruent, you would think it would be a rectangle. But I know a rectangle has all 90-degree angles. Okay? So this is not a rectangle. A rectangle has 4 right angles. So if this is 60 degrees, and the diagonals are congruent, it's definitely not a rectangle. Now, is it a rhombus? Well, I don't think we have enough information to say that. So I'm going to leave that blank for now. Let's go over to this one. This one says the quadrilateral has perpendicular diagonals. So the diagonals are 90 degrees, all in the middle. And it also says it has 4 right angles. Now, is this a rhombus or a rectangle? Well, it's definitely not a rectangle because a rectangle does not have perpendicular diagonals. Okay? So right now, this information tells me it's a rhombus. Now, is it a rhombus? Is there a rhombus that has 4 right angles? The answer is yes. We call it a square. A square is a rhombus because it meets all the requirements that a rhombus has. 4 congruent sides, diagonals are perpendicular, 4 right angles, it's parallel, so this is a rhombus. Example A, we didn't have enough information, so that one is neither.